In this video, we are going to discuss eddy currents. It's a short topic. In fact, it's the last topic in electromagnetic induction. In the next video, we are going to start alternating current. We'll quickly wrap up alternating current and then we are going to move into section B. Okay, so let's see what this eddy current is. Now we've seen that whenever the magnetic flux linked with a coil changes, an EMF is induced in the coil, or so to say, a current is induced in that coil. And we also looked into Faraday's laws and Lenz's law, of course, which governs this phenomenon of electromagnetic induction. Now, the question arises, what happens when the magnetic flux linked with a conductor on the whole, not just a coil, but a conductor is changed? So, we have this conductor, okay, initially we don't have an induced current here, okay. So, we have this conductor. This conductor right now, it's a metallic plate, say for example. This metallic plate is outside this perpendicular magnetic field, perpendicular, and of course going into the plane of the body. Alright, so we have this metallic plate outside the magnetic field, we apply a force and then we bring this metallic plate into the magnetic field. So what is happening? What we are doing is, we are changing the magnetic flux linked with the metallic plate. Initially when it's outside the magnetic field, there is no magnetic flux linked with it, of course. Okay, the magnetic flux linked with it is zero initially. Now the moment we bring in the metallic plate inside the magnetic field, there is of course a magnetic flux. Alright, so therefore there is a change in magnetic flux from nothing to something. So whenever there is a change in magnetic flux linked with a conductor also, what happens is a current gets induced, of course obeying Lenz's law 90. Now, in this metallic conductor, the difference is there will be circular currents like this that is induced throughout the volume of this metallic plate. Okay, and since it's a circular current like this, which forms like a whirlpool, okay, in water. So since this is a whirlpool or eddy that is formed in water, so therefore the name eddy currents. This is also an induced current, mind you. Okay, so a circular current gets induced throughout the volume of the conductor. Now mind you, the direction of the eddy current will be such that it tries to oppose the cause producing it. That is, it is obeying Lenz's law, mind you. So in this case, when we are trying to bring the metallic plate inside the magnetic field, what is the cause of this induced current? The cause of the induced current is the sudden increase in the magnetic field or magnetic flux. Because initially there was no magnetic flux linked with the conductor, and when we bring it inside, there is magnetic flux linked with the conductor. So the increase in magnetic flux is the cause producing the induced current. So, in this case, therefore, when we are trying to bring the metallic plate into the magnetic field, the direction of current will be this. So, flowing in the anti-clockwise sense, such that the direction of the current wants to decrease the magnetic field. Apply your right hand thumb rule and see the direction of the magnetic field due to this current is coming out of the plane of the paper. So the direction of the current is such that it wants to decrease the change in current, because it is the increase in current which is generating this induced current. So this is the effect therefore, and this effect wants to decrease the cause producing it. Alright, and the cause, as I already mentioned, is the increase in magnetic field, so this thing wants to decrease the magnetic field. Okay, likewise say this metallic plate is now taken out of the magnetic field. It is inside the magnetic field. Okay, I want to take it out. So what happens? Again, there is a change in magnetic flux from something to nothing. So since there is a change in magnetic flux, current obviously will be induced. The direction of the current will be such that it wants to oppose the decrease in magnetic field, so to say. So therefore current will be induced. in this direction. You can see the direction of the magnetic field generated by this induced current is going into the plane of the board, applying our right hand thumb rule. Okay, so therefore the current is induced in such a way that it wants to increase the magnetic field. Okay, because it is the decrease in magnetic field that is the cause producing this eddy current. Now, one of the effects of eddy current is that, like hysteresis, okay, that we've studied in magnetism, like hysteresis, eddy currents also produces heat energy. Now, if there's a lot of eddy currents that's generated, then it produces a lot of heat, remember. Okay, so to say, eddy currents also causes a lot of loss in energy in the form of heat. Now, the uses, it's used in electric brakes. It helps in damping, which is used in galvanometers. It's used in electric brakes. Okay, now electric brakes are used in your magnetic trains. Alright, so and it's used in induction furnace. Now, since it generates a lot of heat energy, so therefore it's used in induction furnaces, which is used to melt, metals.